Hi, in this video I will talk about the stack data structure. To better understand the stack, think of these examples. Some books that lay on top of each other, the many layers of a delicious cake that you are about to eat, a stack of boxes inside a warehouse, the towers in the Hanoi puzzle, the stack of dishes that need to be washed but you are too lazy to do that, or the many flavors of ice cream scoops that you dream of. What binds them together is the fact that you can only add and take things from the top of the stack. So it is quite similar in implementation to the queue and can be created as a layer above the linked list, array list, or just the built-in list data structure. The two methods to add and remove elements to the stack will be named push and pop respectively. Besides those, we will implement a method named top to retrieve the next element in the stack, and some additional utility methods like size, isEmpty, and toString. Like mentioned before, the stack can have data stored as a linked list, an array list, or just an array. So, in the case of a linked stack, during the object creation, we store the data property as a new linked list. The array list stack will create a new array list, and the array stack a new empty list. In order to add data to the linked stack, we call the addFirst method on the data property. In the array list stack, we call the add method and give it 0 as the index argument and pass further the element to be stored. For the array stack, we call the insert method on the list with arguments 0 and element as the index and value to store. Let's add one more element to the stack and update the inner data representations. Now, when we remove elements from the start of the linked stack, we call the removeFirst method on the inner list. In the array list stack, we call the remove method from the array list with the index argument equal to 0, and in the array stack, we check if the data is empty, and if not, we call the pop method on the data list. The top method takes the first element from the stack without removing it. In the linked stack, we call the first method on the inner object and then getElement to take the value. The array list stack calls the get method and gives it 0 as the argument, and the array stack just accesses the item from the inner list by index 0. The size method will return the number of elements in the stack. For the linked stack, we call the size method on the data property. The same thing applies to the array list stack, and for the array stack, we get the size using the length method. Checking if the stack has any elements is done by calling the isEmpty method on the data property both in the linked list and in the array list. For the array stack, we check if the output of the length method is equal to 0. Finally, we build a method to output all the elements in the stack. The linked stack and the array list stack will call once again the method on the data. In the array stack, we will join the elements of the list using a comma separator. In the end, let's test our stack data structure. We will use the linked stack, but the output of the array list stack or array stack is the same. So we will create a new linked stack, push 10 elements to it and print it. See the output on the right. Then we pop the first element and get the first one after it. Also, we output the whole stack again. After that, we pop one more element and push one more. Then we check if the freshly pushed element is indeed the first one. That's it for this video. See you in the next one.